Hey, how's it going? So in this tutorial, we are going to be making a target shooter game. So basically we're going to make some targets, they're going to bounce around the screen, and we're going to click them in order to make them disappear. And so we're going to learn how to work with mouse, as well as how to make objects in a streamlined way, and use them all in Pygame. So let's start off with what it is that we're actually going to be creating so we have an idea of what we're working towards. So I'll just hit run here, and this is kind of the idea of what we're going to be making. It has some text telling us how many targets that we have remaining. They're all kind of bouncing around real nicely. And if we click one, color changes again, and after 3 clicks, it disappears, and the number of targets updates. So that's going to be what we're going to be making with this. So I'll stop that, and this is what your screen is going to initially look like when you start the assignment. Some of you may have already worked with Python before, Pygame. Those of you that haven't, let's quickly just run through what everything does. As you can see, the game is already running. If I move my face down here, you can see that we have the screen going on, a little X and button. Probably know what happens when you click the X. It stops the program. But we'll get it going just for a second here. So always starts off importing Pygame and sys. Pygame is going to be the main thing that we use. Sys is only used right here in order to stop the program. And we also import this constant quit that checks to see whether or not this X was pushed. Pygame initialize is setting everything up for Pygame to work. This line here creates the game window using these dimensions. So it is 400 pixels across, 300 pixels down. And it's getting assigned to this global variable called display surface or display surf. Note that it is in all caps, indicating that it is going to be used as a global variable. And finally, this sets the text up here. It's certainly not going to be called hello world. Let's call it target shooter. And let's also learn how to spell. There we go. This is the main loop. So every time this loop runs, one frame is calculated and drawn. And inside of it, we have our event loop. This checks every event that has occurred since the last time it checked. Events are any kind of input from the user. So if you push a key, or you click your mouse, or even move your mouse, each one of those creates an event. And this handles every event that it encounters. Right now, the only thing it's checking for is if the event is the click the button to stop the program event. And that's what this is checking for. So if the event type is quit, then quit Python or Pygame and exit the program. This is a really important line right here. This actually updates the screen so that you can actually see the next frame. This always happens last every time you are running the loop. So that's why it's down there. And we'll put some space between that and what we're actually wanting to do. I'm also going to fix the indentation because the way I like to do it is that one tab is a single indentation. Makes things a little bit easier for me. But yeah, that's kind of what all this code does right now. And when we run it, we just get this black window. Doesn't really do anything. So what we're going to do is we're going to start off with getting some more stuff imported. Besides Pygame and sys, we're also going to want to use the math module for this because if we're bouncing around, having some stuff happen, we're going to need to do some math, particularly trig. So you might want to remember your trig and perhaps some of your physics. There's some random elements to this, mostly just the random placement of the different targets and which way they start off moving. So for that, we're going to use our randint method. So from random, we're going to import the randint method. We're not going to use all of it. This may as well import the thing that we're going to use. Besides importing the quit constant, the other kind of thing that we're going to be looking for is most button down. We want to know when the user is going to click. So that's the other kind of event that we're going to be looking for, and we're going to import that as well. The last thing we're going to use is from the NumPy library. We're going to use the array data structure. And this works just like a vector. And if you might have done any physics, you know what a vector is. If you haven't, we'll talk about it when it comes up. But this is going to help us handle the position and the direction that things are traveling. And it makes it a whole lot easier than having to do all the math ourselves. So let's set up some of our constants and initialization that we're going to be using. I don't like to typically hard code the size in here. I like to be able to set those independently because I might need to refer back to them in the code itself, and I don't want mysterious 400s and 300s showing up in my code. So instead I'm going to create some global variables. Like the width is going to be how long it is. It'll be 600. The window height will be 400. So a little bit bigger than the screen that we have right now. 600 by 400, but it seems like a pretty good size. And then let's use those here when we're creating the screen. So window width and window height creates the screen the size that we want. We've already set the caption to what we want it to be. And the last thing that we're going to want to do is we're going to want to create a clock. Pygame time clock. And I need to learn how to spell Pygame. And what this is going to be used for is to set the frame rate for our game. So if it's going too fast or too slow, we'll be able to use this to adjust that. Beyond that, we're also going to be creating some colors. So Pygame does have built-in color constants you can use, but if you haven't used Pygame before and you want to make some custom colors, this is going to be the way that you can do it. So we're going to create a red, and red is going to be a Pygame color. Note that color is in the American spelling, not the Canadian. No one's perfect. And then we give it 3 numbers here. Those 3 numbers are the RGB values of the color that you want. So if we want red, we want more red, and then maybe a little bit of the other 2, green and blue, because otherwise you kind of get an oversaturated color. And we'll do the same thing for a couple more colors. So let's make a blue. Is a Pygame color. And we'll just keep things the same. So 50 red, 50 green, and 200 blue. And we'll make a green. A Pygame color. And it'll be 50 red, 200 green, and 50 blue. Beyond that, let's also make black and white. So black, and also spell Pygame correctly. Let's make a count of how many times I misspell Pygame. I bet you it's going to be a lot. Pygame, well, we're at like 4 now. Color, black is 000, so none of the colors at all. White is all the color. 255, 255, 255. And RGB colors, the largest value you can get is 255. Okay, so don't go above that. Weird things might happen. But that is all of the colors we're going to use. You can customize this if you want, but those are the colors that I'm going to use. The next thing we're going to also want is a useful helper function. So remember I said that array here is kind of like a vector? It is a vector. But The downside is it doesn't have all the vector operations. So you can do vector adding and other stuff with it, but it doesn't have a built-in way of finding how long that vector is. And so we're going to use a custom function here called getLength that's going to take in a vector, and it's just going to return how long that vector is. And if you remember anything from math, or at least anything from physics, you know that we can use Pythagoras to get the length of a vector. Those of you that have not done physics, a vector is really just, for our cases, two numbers, which is the x position and a y position. So if I have a Cartesian grid, I can say 5 to the right and 3 up, and that would be a vector where the first number would be 5 and the second number would be 3. And if I want to know, okay, what is the length from 0, 0 to that point, well, that creates a triangle with side lengths of 5, 3, and the length of that vector. And we can use Pythagoras in order to figure out what that length is. So we're just going to write Pythagoras. And Pythagoras said, okay, get the x position, square it, then get the y position, square it, and then add the two together, and finally take the square root. For those of you that don't know, taking something to the power of 1/2 is the same thing as square rooting it. Math does have a built-in square root function, but we can just use this. Also remember that double times means to the power of. So this is squaring. Okay? This is getting the first element of a vector, second element of a vector, and a vector works very much like a tuple or a list. So that is going to be a little helper function that we use, and then everything else is all going to be done by the object classes. So let's define the classes as well as the main functions of those classes, and then we'll start filling stuff in. Well, the most obvious class that we're going to have is the target. We need a bunch of targets. Let's make a target class so we can make a bunch of target objects. So class, we'll make a target. Note that my class name is capitalized. That's how we tell if something is a class or a variable or function. It's going to have some additional parameters, but the main functions that pretty much every object you're ever going to make for a Pygame object is going to have 3 different functions. At least these 3. Maybe more, but at least these 3. You have your constructor function. I'll put in pass, just as placeholder code. We will replace that when we actually write the function. The second thing that you should have is a draw function. This will be the code that actually draws the object to the screen where it needs to go. And finally, an update function. And this is going to be the function that we call in order to update the object, either by moving it or clicking it or whatever it is that we need to update. So pretty much every time you create an object in Pygame, or really any kind of game engine, you typically have these 3 things going on. A constructor function that will set everything up, a function dedicated to drawing it, and one dedicated to updating it. Sometimes these two get put together in some situations, but in modern game engines that doesn't happen because the drawing and the updating happen at different frame rates. For example, you might be playing a game at 120 frames per second, which means that it is being drawn 120 times per second, but the physics of what's actually happening actually only gets updated maybe 40 frames per second. So you might see a lot of stuff moving and updating very quickly, but the underlying physics gets updated much less often because it's typically much more time consuming. And in order to maintain game performance, physics updates happens less often. So that's why these two are separated. And it's also a good way of kind of thinking of these things as doing different things. So we've got the target class. What else we're going to need? We're going to need a text class that's going to create the text objects for us. We're only going to use it for one, but when you are expanding on this, you may want to add text for other things. So it could be useful for having an entire class for it. So we'll create a text class. And this is going to be exactly the same thing. It's going to have the same three functions. It's going to have a constructor function, a draw function, and an update function. And then I think the last one that we're going to create is just a main object that's going to kind of handle how everything interacts and keep track of all the different game elements. So let's create a main object, which, guess what? The main object has the same three. Even though the main object does not refer to any particular game object, the constructor function will construct all the game objects for us all at once. The draw function will then call the draw function of every game object, and the update function will be responsible for updating every game object. So that's the reasoning behind this. And then our driver code is going to be pretty simple. Most of it's going to be done actually in our main function here. What else can we do? Let's also flesh out the rest of the functions that these are going to need. So every game object is going to pretty much have these three, and then we'll add a couple more to it to handle the specifics for those particular objects. So the main object, besides doing that stuff, we're also going to give it a event handler. Function that is going to be responsible for, well, this event loop. So main is going to take care of everything. Our driver code is really just going to be calling the main's different functions. So we're going to cut that out, and we're going to put it right there. So that's going to take care of all our events. When we have clicking and stuff going on, we will take a look at it there as well. In fact, we could probably already create our main loop here. So before we start, we need to create a new main object. We haven't created the constructor, but it's going to happen. And then in the main loop, we just need to call the different main functions in the order that they should happen. So the first thing we should do is we should handle all the events. Then we should update all the game objects. Then we should draw all the game objects. That's pretty much it. Then the last thing we're going to do is we're going to enforce a frame rate. So we're going to take that clock that we created, and we're going to say only run this at 30 frames per second. The reason why we do this is because if you do not include it, it will just run the frames as fast as it can. Some frames will run very fast, sometimes it will have more it has to do, and you'll notice that your game speed is fluctuating and it feels like it's pausing and hanging a lot. But if we enforce, okay, no more than 30 frames per second, that really helps smooth things out. So you can play around with that in order to make it feel right. 30 is probably a pretty good number. Maybe you might want to go higher, but we'll test that out once we get things going. But that's really all of our main driver code. Now we just need to set everything else up so that our driver code does what it needs to do. So let's go back to our target class, and let's flesh out some of the additional things that it's going to need. So certainly we got constructing. It's going to draw itself. It's going to update itself. But let's handle a couple more things that are going to be useful. One thing that you noticed is that the targets were bouncing off the walls. So how about we create a function that will handle bouncing off the walls. So we'll say def wall bounce. And we will use this in our update method to handle, did it run into a wall? In that case, let's bounce off that wall. Also, our targets are going to be clicked on. So we have that interactivity that these need to have. So let's do two functions that are going to help with that. We'll have a did click function. What this function is going to do is just return a boolean of, depending on where did they click on this target? And then we'll have an onClick function. And we'll say, okay, if this thing did get clicked, what should happen? Okay. So that's all we need for that, really. And that is all the functions that we need to create for all of our different game objects. So let's get started filling everything out. Let's work on the target for now. Let's make some class variables. So when you create or assign variables in this section up here, not in the constructor function, but between the class and the first function, those are called class parameters. And those are the same for every single object. So it's not like one target has, like, so each target will have a different position that is unique to that particular target. So those cannot be class parameters because otherwise all the targets would be in the same place. But every target started with the same color and went through the same progression. So that's going to be something that is the same for every target, is the colors that it uses. So that's what we're going to use is set up here. It's the stuff that's going to be the same for every target. So we're going to have what I call the main colors. And this is just going to be a dictionary of what 3 colors do we want to use as they are clicking. And I am going to organize them so that the last color it turns is first and the first is last. The reason why is because we're going to have a variable called hit points that is going to keep track of how many times has this thing been clicked, in a sense. And we can use that as an index to identify, okay, based off of how many times it's been clicked, what target should it be? And that's going to be the reason why we do it in this order. So we're going to say it's going to finish off red. In between it's going to be blue. But it's going to start off green, just like that. And we've already created these colors, so that's all done. But we also got that ring in between them. Remember, we were creating these targets. And so the inner and outermost were the same color, but then we had a white ring in between them. And I'm going to call that the secondary color. And secondary color is going to be white. You can change these to be whatever you want. These are just going to be the colors that I use. And this is going to be the same for every single one of them. Alright, with those class parameters created, let's start with our constructor function. So when we construct a target, we're not going to pass anything to it. It's just going to randomly create a target somewhere on the screen with some random initial velocity. That is the goal. So, if you noticed in it, we also had, actually maybe I'll run it one more time just to show you guys what we're creating here. Blah. So you notice some of the targets are big, some are small, some are fast, some are slow. So we're going to want to randomize that part as well. So we're going to need to create a speed, randomly select how fast this thing is going to be going. And so we'll say, using our randint function, we'll say it's going to go between 2 and 4. What does that actually mean in principle? It's how many pixels does it move per frame. Typically, you're going to want to keep this fairly low because even though it sounds like it's not very much, remember that this is running 30 frames per second. So in 1 second, if it's got a speed of 4, it's moving 120 pixels every second. So it's actually pretty fast. Then we've also got the self.size. And this is going to be a little bit bigger. Rand int once again, and we'll generate something between 15 pixels and 25 pixels. I'm actually not going to call it size. Let's make it a little bit more clear. This is going to be the radius. Because if we do just size, like, well, is this the radius of the target? Is this the diameter of it? What do you mean by size? So we'll keep it a little bit clearer. This is the radius of our target. So we created that. We got initial speed and initial size. Next, what we need to do is we need to have a random position that we're going to put it in. So these are not, the X and the Y position are not going to be stored as X and Y. Instead, we're going to store it as a vector, but we need to construct the X and Y position first. So X and Y position, for our purposes, we're actually going to need it to be a floating point. So I probably should have used a different random function that did not give me integers, but we are going to convert to a floating point for our purposes. So float, and we're going to create a random integer that is, and we need it to be fully in the screen. Since we have the radius now set, we can use that in order to determine what is the range that would be acceptable for this thing in order to stay on the screen. So the farthest left it can go is going to be its own radius. If it's more to it than that, more left than its own radius, then its far edge, the left-hand side of it, would be slightly off the screen. Okay, so that's why we're using that. And likewise, we're going to want to go from the edge of the other side of the screen, but offset it by its radius as well. We don't need this thing to be running. And so what we do is we're going to get that window width and subtract our radius just to make sure that we stay on the screen when we are constructing this thing. And then we'll do basically the same thing for Y. In fact, I'm just going to copy this, replace X with Y, and replace window width with window height. And that is a random Y position now created, ensuring that the target is going to stay fully in the screen. So that's important. Now that we've created a random X and Y position for it, we can use that to create our position vector. So I'm going to say self.pos, pos for position, and use our array method to create a vector with the X and Y that we just created. So the first number is going to represent its X position, the second number is going to represent its Y position. An array is very much like a list or a tuple. We can access it exactly the same way. The only thing that's really important difference is that it can also do vector operations. So we can add vectors together rather than concatenating this together. So that is that purpose. Next, we need to say go in a random direction. We already got the speed that it's traveling. Now we need to figure out what direction do we want it to go. To do that, we need to randomly pick an angle to go at. So I'm going to create an angle variable, and let's just randomly pick an angle to go. So we could say rand int somewhere between 0 and 360 degrees. That's the whole circle, so that randomly selects stuff. However, we don't want to work in degrees because Pygame does not work in degrees. In fact, very few things actually work in degrees under the hood. Everything typically works in radians. So we're going to use our math library to convert that to radians. Okay? So now we got a random angle between 0 and 360 degrees, but converted to radians. If we wanted, we could have also just created a random number between 0 and 2 pi. It's the same thing, but sometimes degrees is a little bit easier to think in. Now that we got the angle, we're going to do kind of the same idea here and get the x and the y velocities given the speed that we have and the angle that we're traveling in. And for this, we're going to need to do some trig. So the Vx, or the x velocity, is going to be whatever the speed is times, and we're looking at the x direction, and if you remember from physics, the x direction is associated with cosine. So we're going to do math.cos to get the cosine of the angle that we just created. That's it. So Vy, same idea, self.speed times math.sine of the angle that we just created. That gets us the x and y components of our velocity, and now we are ready to create our velocity. So we'll say self.velocity equals an array of Vx and Vy. You might have noticed that I've been not just putting in x and y for the array, but I've been giving it a tuple instead. The reason why is because array does not create objects from its individual components like you could with like a list or something. Instead, it creates an existing data structure and converts it to an array. So I converted it to a tuple. You could do the same thing with a list and it would work just as well. But you do have to put it into a list or a tuple first, then convert it to an array so we get the vector that we want. Now that we got the velocity, a couple more things that we need to set up is how many hit points does our target have? And it has 3 hit points. So it can be clicked 3 times before it disappears. And based off of that hit points, we can now also set what is the color that we want it to draw at. So I'm going to call it, we already have the secondary color, which is white. So we're going to have the main color is going to be on the main colors that we created, that list, and then we're going to use that hit points as an index. So we need to subtract 1 because our indices only go 0, 1, 2, not 1, 2, and 3. But otherwise, we can use this in order to set up what color do we want it to be. And that's it. That is our constructor function. We got a randomized speed and size. We created a random position that ensuring that it's going to be inside the screen entirely. We randomly generated an angle and used that to get the x and y velocities and assign that also to a vector that we're going to be able to use. Gave it a number of hit points and set what the main color of the target is going to be. I suppose next thing we should do is maybe the draw function. So this is going to be pretty simple. A target is really just going to be 3 circles. So we need to draw these circles on top of each other, and we need the biggest one to be in the back. So we're going to draw the biggest first, and then we're going to draw smaller circles inside of it. So to draw a circle, we do Pygame draw circle, and this needs to be given 4 different pieces of information. First is what surface do we draw it on? We only have the one surface, and that's the main window, so that's going to be our display surface. The next thing we need to give it is the color. The color is going to be, well, for the outermost ring, that's our main color, so self.main color. Then we need to say, okay, where's the center of this circle? That's going to be given by the position that we created, so self.position. And finally, how big is the circle that we want to create? And notice it's asking for a radius. So we're going to do self dot radius. That's it. That's created our outermost circle. Now we just need to do that 3 more times, or 2 more times. So I'm going to copy all that, because a lot of this is going to be the same. Let's shuffle that over so that we can see things a little bit nicer. And the only thing that's really different for the other two is the size, and for the middle one, the color. So they're all getting drawn to the same one. The second one is going to be our secondary color, because that's going to be the white in between the two. So secondary color, still in the same position. Position is represented by the center of the circle. When we're doing rectangles or anything like that, position is always the top left corner. Circle is different, it is the center. So that doesn't change. And then we don't want it to be the same size as the other one. So instead, we're going to make it 2/3 of its size. And then down here, the innermost circle is going to be the same as the outermost, so same color. Position stays the same, but we need to make it smaller, and this time it's going to be just 1/3 of the original size. So, gets smaller as it goes, colors alternate, but everything else stays the same. And that's it. That is all we need for drawing our target. Update is going to be also pretty simple. On its own, we're just going to be checking if we did a wall bounce, and it's going to bounce off the wall. So self.wall bounce. And wall bounce is just going to be responsible for changing the direction that we're traveling in when we hit a wall. And then after we've changed the direction of travel, if needed, we just now need to update the position. And the way that we do that is we get our position, and we add to it our velocity. That is all there is to the update. That is typically how things move, is you just take where you are, add your velocity, that's where you are in the next time step. If you want to get really complicated, you can start adding like stuff like acceleration, which allows you to create like real physics. But in terms of just basic kinematics, that's all there is to it. Wall bounce is going to be a little bit of work. Let's do the other two first, just because they're a little bit simpler, and then we can talk about the wall bounce and the logic behind it. So did click is going to need to have a parameter passed to it, and because we need to know where did they click, the location of where did the mouse get clicked. That is what we need to get passed to us. And so if this is where we got clicked, how can we tell did they click on the target? Well, what we can do is we can find, okay, what's the distance between where they clicked and the center of the target, and is that distance less than the radius of the target? If it is, they clicked on the target. Okay? That's the logic that we're going to use here. And so in order to get the distance of between the center of the target and where they clicked, we can use our getLength function. So getLength, we're going to get the length of a vector, and if we want to know what's the vector between two positions, we can just subtract them. So we can take the location of where they clicked, subtract the position of our target, and say, okay, well, what's the length of that? And is that less than or equal to our radius? If it is, then we should return true, you clicked it, or return false. Sounds like we should use an if statement here, but since we're just returning the Boolean itself, we don't need to actually do that. We can just actually return this on its own. So we'll evaluate, is this true? Is the distance between the location and the position of the target less than or equal to the radius? And return whatever the result is. There we go. That's all there is to it. On click, well, there's only two things to do. We need to reduce the number of hit points, and we need to change what the color is. So let's do that. So on click, if this thing gets clicked, hit points should be reduced by 1. And our main color should be updated. And we do exactly the same code that we did before, which was the hit points minus 1 as the index. So reduced by 1, move to the next color, and assigns it to the color that we're using in our draw function. That's it. Alright, so now I suppose we should just do this wall bounce. Okay, so what we're going to do is we're going to take a look at the 2 side walls, figure that bounce, and then the top and the bottom, and figure out that bounce. And bouncing is actually really simple, at least when you're bouncing off of vertical or horizontal surfaces. First we need to check, did they hit one of these walls? So first thing is that if statement. How are we going to check, did they hit that wall? So we're going to look at the 2 side walls. And if we're going to look at it, if they hit the 2 side walls, that means we need to look at the X position of our target. So let's get that X position. Where is it in the X space? And is it less than its radius? Or is it greater than it's the length of the window minus the radius? So basically, remember, we were using this as the 2 sides of where the target can go, and if it goes outside of this, then it's outside of the window. This is kind of like how far left it can go, and this is how far right it can go. So we're going to use those in order to determine, did it go too far? So if it is less than the radius, that means it is too far to the left. And if it is greater than window width minus the radius, then it's too far to the right, and it's hit either one of those walls. So let's come back down and just check if either of those things are true. So we already checked if it went too far left. And did it go too far right? Is it greater than the window width minus its own radius? If either of those things are true, it has hit one of the 2 side walls. And if it hits a side wall, what should happen is its X velocity should flip. So if it's traveling to the left, it should now travel to the right. If it's traveling to the right, it should now travel to the left. But the Y position part will stay the same. So if it hits kind of like up like this, it'll go like this. It'll still be going up. Only the horizontal direction gets flipped. And so how do we do that? Well, we get the horizontal velocity. Remember, this is the velocity vector. First thing that we put in was the X velocity. And in order to make it go the other direction, we just really need to flip the sign from positive to negative, which we can do by multiplying by -1. If it's positive times -1 is negative. If it's negative times -1 is positive. That's it. So that handles the left and the right. And guess what? The top and the bottom are going to be very similar, just we're going to be looking at the Y position and the Y velocities. So I'm going to take this, copy and paste, and put in 1s because we're looking at the Y's, as well as change window width to window height. And that's it. That's now done. And now it will properly bounce off of the edges. Okay? So, let's skip on the text for now. Let's go and develop our main so that we can actually populate our screen with some targets and see if our target class is working how it's supposed to. So, in our main, we're also going to want to make a class parameter, something that doesn't change. And what we're going to do is we're going to say the starting targets. How many starting targets should we start off with? I'm going to say let's start off with 10 targets. So, if you want, you can change that higher or lower. Remember, if you go really high, that's going to start affecting your performance. I don't know how high it's going to affect it, but I imagine once you start getting like 50 or something, it might get a little excessive. And then what we're going to need to do is we're going to need to construct these targets. And what we need to do, so we'll say self.targets, target, and we're just going to create a list that contains all of the targets. So we can loop through it real nicely, makes things a whole lot easier, rather than have to go and create individual target variables for each one. And we could do this with a loop, but I am going to be a little bit fancy here, and I'm going to use a list comprehension. So list comprehension, it says make a list, and we're going to make a target. So call the target constructor. For an underscore indicates that I am not using this iterator variable in the loop. Typically we do like for I in range or whatever. For underscore means I'm not going to be using it. But we could put I there if you really wanted. So for underscore in range self dot started targets, and that's it. So it's for blank in starting target says do this 10 times, and what it's going to do 10 times is going to create a target and put it in the list. So this creates 10 targets and puts it on the list. Okay. Draw function. Draw is going to be easy. The only thing we really need to do is, well, we need to draw the background. So display surface, we are going to fill it with the color white. You can put it whatever color you want, but I want my background to be white. After that, remember that you always draw the background first because you want to draw things on top of that. If you do this last, all you're going to see is a white screen. Okay? So make sure you put that first, then draw your stuff on top of it. Then we're going to loop through our targets. So for target in self.targets, targets, we're going to get that target and call its draw function. That's it. So for every target that we got, draw it. Simple. Update. Same idea. We're just going to, well, we don't need to draw anything. It's just going to be calling the update function of every one of those targets. So we're going to say for target in targets again, or self.targets. Take that target and call its update function. That will update all the targets for us. Event handler. We will not handle quite yet, but this should be enough that when we run it, we should see a whole bunch of targets bouncing around. We're not going to be able to click on them. It's not going to have any of that functionality, but we should be able to see that most of our target class is in fact working. So let's expand this window a little bit. Hit run, see if there's any problems. Oh. Did anyone see that? I should now be calling a list like it's a function. Did I make a mistake? That's only it. So let's try that again. Hey, there we go. All bounce around real nice. They're all green like I wanted them to. Bouncing seems to work pretty good. They're different sizes, different speeds. Looking pretty good. So stop that. Let's get the clicking working, I guess. So that's going to be handled by our event handler down here that goes through all the events. We're already checking to see if they quit the game. So the other thing that we're going to want to do is did they click the mouse? So let's look for that event. So if event.type equals mouse button down. Oh, double equal. If it did, what do we need to do? Well, we need to know, okay, they clicked a button, where did they click the mouse button? Let's find that out first. So we're going to say the location is going to be where did they click the target, and we are going to, well, the way that we do that is event.position. That is telling us where did this event occur. Not all events have this, like the event type quit does not have a position, it's just quits, but it's a mouse event, it's going to have a position. But for our purposes, we are going to need this to be a vector, an array, so we can do the vector operation, because remember our did click function is checking to see what's the distance between the target and where we clicked. That requires a vector operation, so we need to convert this into an array. And then we need to go and loop through our targets and see if we clicked any of them. And if they did, we need to do something about it. So let's do that. So for target and self.targets, let's loop through all of our targets. And let's check, okay, if for a target, did we click it? That's the location of where we clicked. So, okay, target, this is where we clicked. Did we click you? If we did, what do we need to do? Well, I'm going to do this in two parts. First, I'm going to say if the target's HP is 1, meaning it's on its last hit point, and we just clicked it, guess what happened? It died. Yeah. And so we need to get rid of this target because it no longer exists. It died. How do we do that? Well, we're just going to remove it from our list of targets so that we don't loop through it anymore. Self.targets, we're going to remove the target that got clicked. There's the last time it could get clicked, and now it's gone. Okay? So that's what's happening there. Otherwise, so we clicked a target, but it wasn't on its last hit point. Well, now it's time to call the onClick function for that target. So it knows what to do when it gets clicked. And just so that we don't click on multiple targets in one click, we're going to break out of our loop here and say, okay, you can only click on one target per click. If we do not have this, and you notice that when we're playing or ran the game, targets would go behind each other. This would mean so that if you clicked on targets that were behind each other, they'd all get clicked. But if we break, then only one of them gets clicked. Okay? So up to you if you want to keep it like that, but I find it makes sense to say you can only click on one target per click. And that part is now done. So now we should have something that's kind of game-like. Let's run it again. And now, can we click on stump then? Let's click on this one. Turn blue, supposed to. Click on again, turned red, perfect. And if I click it one more time, gone. Perfect. Looks like it's working just how we're supposed to. Oh, got that one. And if I'm not clicking anywhere on it, nothing happens. So it looks like our click detection is working correctly. Perfect. So that only leaves one last thing for us to work on. And that is our text. So let's create our text class. So this is going to be very kind of abstract. You can use it for whatever you want, but the only thing we're going to be using it for is to keep track of how many targets remain. You may want to use this for more stuff afterwards though. So this is going to need to have a lot of information when we first construct it. First, it's what is the text is it supposed to show? Second is what position is it supposed to be in? How big of the text should the text be? We're going to give it a size of 30 for now. That's a reasonable size, but you will be able to specify if you want for it to be something else. And also, what color should the text be? And let's say that it has a default color of black. So by default, all of our text is going to be black unless we specify otherwise. So now we need to start basically just assigning all this stuff to instance variables so that we're going to be able to use it. So we're going to say self dot the font size is just going to be the size that we passed it. Simple. Self dot font color is going to be the color we sent it. Position is going to be the position that we sent it, and what the text actually says is going to be the text that we passed it. So we need to at least tell it what text to show and the position to show it, but we also have the opportunity to change how big it should be and what color it should be. Once we've done that, we now actually need to create the text itself. Okay? So, the way that we do that is we create the font that we're going to be using. You can use any kind of font. We're just going to be using a default font for this. So, Pygame, we're going to create a new font. The first argument is what is the font name. I'm not going to use any kind of special font. So if you put in none, that's just going to use the default font. So it's not going to look very pretty, but if you want to change it to a different font, Helvetica or something, you would handle that right there. You may also want to assign it the fonts that you want to use when you're doing constructor, but I'm not going to do that. It's just something that you might want to think about. And then we need to also say how big is the font. Okay, so that's creating the font that we want. And that doesn't actually create the text itself. That's just saying when we are creating a font or a text, this is the font that we're going to be using to create it. What we're going to do, let's do the update next. So update will be passed what is the text we want to update the text to. And this is going to do most of the work for us. The draw is actually pretty simple. So we're going to update the text to show the to be the new text that we passed to it. We're going to now use that font that, or we're going to, sorry. Yeah, we're going to render the text using the font that we created. So self.theRendered text is going to be using that font that we created. We're going to render some text. The text that we want to render is self.text. The next thing that we want to do is I forget what the second thing in render is. Anti-aliasing, Boolean, we'll say true. Probably won't make a big difference, but it should make it look a little bit nicer, or at least remove any kind of artifacts. Sometimes you get like jaggy stuff happening if you don't have anti-aliasing happening. And then finally, what is the color of the text? And that's self.font color. So that renders the text. Next, we are going to need to get a rectangle that is the size of this text that we created, because that's going to help us actually draw the thing. So I'm going to say self.rect, the rectangle that contains this text is going to be getting that rendered text that we just created, and we're just going to say get the rectangle. And this is just going to give me the rectangle of how big this text is. This rectangle does not have a position quite yet. It defaults to 0, 0, but it will at least tell me how big it is. Finally, we need to now assign this rectangle to be in the position that we need it to be. So I'm going to say self.rect. The top left is going to be in the position it needs to be. Okay, so it says get that rectangle that we just got and move it so the top left corner is in the position that we give it. Okay. Now that we've gotten our update function done, we're actually going to call it in our constructor function because we need it to render and all that stuff, and rather than rewrite code, let's just reuse it. So we're going to say self.update, and actually I suppose we don't even need to do this since it's already going to be handled by our update, and we'll just pass it to text. And so when we construct it, it'll automatically generate all this stuff we need to actually draw it. Now, the draw function is going to be pretty simple. We're just going to get that display surface, and we're going to say we're going to blit. Blitting is like putting one surface on top of another. Most of the time when you've been working in it, you may have just had the display surface, but this rendered text is also a surface, and it has the text written on it. So when we want to put one surface onto another, we use this blit method. Okay, so it said paste this surface onto another surface. And so what we need to do is we need to say what is the surface that we are going to be blitting. So we're putting it onto this surface. The surface we're going to be putting onto it is the rendered text. And then we need to say where does it go, because the surface doesn't say where to put it, just what to put on it. Where to put it is given by our rectangle that we created. And so that's why we needed to do all this work for our draw function. This to actually create the surface of the text, and then this to determine where it needs to go. But that's it. That is our text function, and it will now allow us to update and display it wherever we want to put it. So let's make use of it. Let's go back down into our main object, and let's create a new text object that's going to keep track of how many targets are still remaining. So we'll say the score text is going to be a new text object. The text that I want to show is going to be targets remaining, and the number of targets remaining is going to be the self.starting targets. Oh, looks like my landlord just messaged me about something. So, guys, we're just constructing it. That's how many there are going to be. Okay. Also, I need to say where is it going to be. And we're going to put it in the top left corner, but not all the way. I'm going to kind of bring it away from the edges a little bit. So I'm going to say let's move it 10 pixels from the left edge and 10 pixels down from the top edge. Okay. This does not actually need to be an array. We could do it, but since we're not going to be doing vector operations on this, leaving it as a tuple is perfectly fine. And I suppose I should really fix my naming over here. Self.score text. Yeah, that looks a lot better. So we created it in our constructor. Guess what? We're also going to need to draw it. We're going to draw it after our targets. That way, if a target goes over top of it, it will show underneath the text rather than over top. So we're going to say self.score text, call that draw function. And the update. After we've updated all the targets, we now need to update what the text is saying because it might have changed. We don't necessarily have to do this every time. Like we could be handling it down here, but it'll be fine to do it here. So we're going to say self.score text. We're going to update, and the text that you need to show is going to be basically the same thing here. So that's going to be the new text. Might be the same as the old text, who knows, but it's not the number of starting targets. Instead, it's going to be the length of self.targets. Remember, self.targets is a list containing all the targets. The length is how many targets are in it, and so that'll be a way to verify that we got the right number. Okay? And that should be it. So, let's test this one more time. Hit run. And there's our text. Shows the right number. If I click, still good. And it went down to 9, just like we want. Perfect. So, that is the end of this tutorial. We have created a simple target game. We've looked at how it is that we get proper motion and bouncing going on by having a position and a velocity vectors. We've seen how to create text and how to update it, as well as the most common ways to actually organize your code using object-oriented programming by creating every game object as its own class and give them the basic functions that pretty much all of them will have: a constructor method, a draw method, and an update method. You might have some extra stuff on top of that, but basically everything they're going to have is going to have those 3 methods to help us organize what we're doing. Okay? So from here, you should comment on all of this code. I have not commented on any of it. I've just spoken about what everything does as we wrote it. So it's on you to actually put in the proper commenting. Also, you're going to want to then build on this and add additional features. Depending on what features you add, that will affect what grade you get in the end. Just handing in a fully commented code would get you a developing 2, and as you make things more difficult, that would enhance this. Some things you might want to consider would be to do some more with the text, have a play again function, and like a menu that pops up after everything is gone. Like if we quickly play through this, you'll see that if we click on all the targets and disappear them all, nothing is going to happen. So you might want to have like a game over and a possibility to play again. You might want to make a button class that will allow them to click different buttons to select do they want to play again. You may want to make it so that the targets bounce off each other. So right now we only have that they bounce off the walls. If you want to put your physics knowledge to the test, you may want to write some additional code that they bounce off of each other as well. Or you may want it so that when you click on one, rather than just simply changing color, it instead splits into 2 smaller ones, and so on. Be careful, that could end up with a lot of targets, but gives you some ideas of what you want to do. You could also make some fake targets that the player needs to avoid clicking, otherwise they lose. Or some sort of score that will give them a higher score the closer they click to the center of the target. So some ideas of what you might want to do when you are further developing on this program. Anyways, we will stop there, and I will see you next time. Bye.